Good morning, everybody. So I'm going to try to do a short rundown of what we do with the water in the industry, which are the challenges that we face when we have to add water to our products, and I'll give you an overview of things that we do at the Coca-Cola company in terms of water. So, water is a key element in the food industry. Food liquids, even solid products, they contain or may contain in their formulas a certain amount of water. We use the water not only in the final product, but we use it also in the manufacturing process, in auxiliary services, and almost in many steps during the manufacturing of a product. In case of a liquid food, the water may represent, from 80% up to 100%, depending on the type of formula. So if you have a mineral water, for instance, or spring or table water, bottled water, the water is 100% there. Well, if you have a juice, the water amount may be 50-60%. If you have a Coke, you have an amount of water around 85%. In the European Union, the water that we use in the manufacturing facilities in food industry must comply with the requirements in the Drinking Water Directive 98/83 EC. Well, if you manufacture mineral waters, there is another directive for that. And this directive set the parameters under which the water is considered as drinkable or potable. So, we as food industry, we source water from different sites. Normally in Europe we are using water coming from municipalities, and sometimes we source our own water from the ground. In case of the municipal supplies, the waters are distributed after having been treated to make them compliant with the criteria in the directive I mentioned before. In case of groundwaters, we have to do the same treatments or similar treatments in order to make them compliant. The formulas that we prepare in the food industry may require other types of water or specific types of water. This means that sometimes when the municipal supply gets into our facilities, we produce some other treatments in order to, let's say, make compatible the water with the final formula. These additional treatments may be simple things like removal of hardness, alkalinity, removal of iron and manganese, that if you would leave these elements into the product, this would cause stains and consumer rejection. The municipal supplies that we receive normally are chlorinated for microbiological purposes. So, and we have to remove the chlorine, and we have to remove some other elements, byproducts from this chlorination, like triolomethanes, before we manufacture the formulas. The thing which is key in the food industry is something that you hear of quite often, and which is called food safety. So food safety means that the things that you will eat are going to be wholesome for you and not going to hurt you. And water is very important because it's a vehicle for bacteria and for other things like viruses. So for us, the treatment of the water is very, very important step. The municipal supplies, before being used, as we receive it through long pipes, normally contain biota, contain flora or bacteria that may interfere with the formulas and may spoil the products. So what we do before incorporating it into the final product is another disinfection, just to ensure that we kill any strain that could have grown in the pipes, biofilms, etc. But it's not only the municipal supplies that we have to treat extra. Also, if we source groundwaters, if they are well protected, show quite high degree of purity. But even these, they need treatments to make them, let's say, compatible with the formula, and also to remove bacteria. Now we are in another era. We are entering the era of the femtogram. Recently, I read an announcement from a company called Shimatsu, who is a supplier of material for labs. They said that they claim that they have produced machines that are capable to detect femtograms of contaminants in foodstuffs. For us, as you can figure out, the quality of the water that we use is paramount, and one of the things that show up in the media and that we see and may cause concerns is all the thing related to emerging contaminants. These emerging contaminants, although the WHO has already stated some years ago that there is no risk related to health because of the small concentrations that may be present in supplies, for us it's something that is causing concern, and it requires that we do extra treatments to remove them from the waters that we use. And for sure, the use of these treatments in the end comes up with higher prices, right? Recently, I got this news. In Sweden, they have inaugurated the first wastewater treatment plant for removal of these residues. So it means that the perception is very important, is there, and the water supplies are working towards the direction of removing these contaminants. Think that for us, a femtogram and nanogram, we understand what it is, but for plain people, when they listen that they hear about some contaminant in water, even if it's at nanogram level, they get scared, right? So that's very good news. And so for us, we need this. We need water of high quality, and quality and food safety of our products is the thing that we work every day in our facilities. So now, in terms of water practices, we are users of water and we must be responsible for the use of this water. We have in Europe, it has been mentioned by the previous presenter, this famous Water Framework Directive, which involves everybody in the water chain in the use of the water at several stages and from different perspectives. So we are water users. The liquid food industry is a water user. And from this point of view, we have to take care of using water rationally and, let's say, not to spill water resources, because, as you have heard before, they are scarce. So, some years ago, our former president, Neville Isdell, did a pledge in Beijing. It was in the year 2007. He promised something which could be at the time a bit surprising. The promise was, I'm going to bring back to the nature the water I use in the manufacture of my products. And this from 3 points of view: recycling, reducing water consumption, and replenishment, which means returning amounts of water which are used in the manufacture, the amount of water which is inside the products. So it's a compromise that was signed with the organization WWF, and since this moment we haven't stopped in doing things. So this is a graph showing from where we source the water at COCA-COLA. We source a lot of groundwater, a lot of municipal supplies, and in 2014, the amount of water of all the facilities we have worldwide, around 800 facilities, the consumption was 304 billion liters of water. Billion liters, American billion, okay, 1,000 million liters. Then, when you browse about water consumption by users, I came up with some figures for the city of Chicago. Chicago is an area of about 5 million people. It's downtown Chicago, it's 2.6 million people more or less. So if you look at the annual consumption average, because the figures, may vary depending on the source, but more or less average, it's about 700 billion liters per year. So the amount that we are using to manufacture all of our products, which are about 500 different brands, is less than half this amount. So, manufacturing a beverage is a quite simple thing. It's not rocket science. So, in reality, what you have is a certain number of processes, and here you have an example of these processes, and the water is used as ingredient and then to clean, right? You have at home dishwashers. After eating, you have to clean the dishes, right? So we do something similar. We have to clean the bottles we use, and we have to disinfect our machines because our filling machines deal with several types of different products. So this is a kind of ladder where you see where the water is consumed in all these processes. And there is a simple manner of making water balances is that having flow meters. So our facilities have flow meters before and after each one of these processes, and this way we know exactly the amount of water that we use in each one of the facilities. And this is worldwide. We don't make differences if we are in India or we are in Africa or we are in Europe, right? So then every time you treat the water gets a value. And so, well, this is an example. This was done with the beer industry together. We did some exercises. So this is something that industrials, the costs are very important because in the end, the costs, you pay that, right? It's the same thing as the Frame Water Directive. They wanted to make us pay, right? But here in reality, you pay. So every product that has an amount of water in, so this has a value. So these are for you to give you an idea of after each process, we have values and in the end, the product has a cost, right? So, all this means that this is very important from point of view of water use ratios. Some years ago, when I started working in the food industry, if I can remember that perhaps about 30 and some years ago, nobody cared much about water. Today, I can assure you that we look for leaks because the water is a precious product. So, and we have a saying in the company that says that every drop counts. This is what we have published in our sustainability memory. Since 2004, the reduction of the amount of water that we use has been of 27%, which is quite significant. And we are still improving because new filling lines come, new machines come, and all these machines help. The new technologies have in mind, as mindset, the water consumption. Finally, we do what we call replenishment programs. Our target was in 2020 to be 100%, would say neutral, I would say to return to the nature, the water we use in the product. This was for 2020, but this year in Stockholm, we already announced that we have achieved this goal. Well, we are not stopping here because it would not be responsible. We have to go further on. And when we talk about replenishment, there are practices that are done related to these. We have done several in Spain, for instance, re-injection of water from after wastewater treatments in the Valencia area to avoid sea infiltration, for irrigation, reducing nitrate levels. We have been doing things on the Guadiana River. There was a big project on the protection of the Danube River. Well, all these things are practices that are recognized by organizations as practices for replenishment. So the other thing is the wastewater. Wastewater in Europe, we have very strict regulations. This is not exactly the case when you go to other geographies. Just back from a trip, I landed from Nairobi this morning, and well, in reality there in Africa, the governments had a lot to do with the wastewater treatments. But despite these, we follow the same European standards there. The authorities do not ask for that, but they will ask in some years because the population and the conditions are improving year after year. And in the end, we have standards and the same standards for every site that we manage. And finally, when in our sites, we do what we call source vulnerability assessments. This means that I need to understand from where my water comes and this water, what I represent in terms of consumption as respect to my neighbors and as respect to the neighboring communities. Also, it means that I have to protect the water, right? So we have mineral water sites, for instance. The mineral water industry, mineral water is something that you cannot touch. If it's contaminated, the authority will withdraw the mineral water denomination. So protection of areas, perimeters of protection, and knowing the activities around the waters is something that it is compelling, and all the facilities apply. And finally, in terms of virtual water, which is a word widely used, we have suppliers, right? All these suppliers use water. We source juices, we source sugar, we source many things that come from the agriculture. So the same policy we try to apply, and we work together with our suppliers so that they are, let's say, they have a mindset and focus set in the water and water practices. So far we have contributed to several agricultural initiatives in 25 countries. This is something quite new. We started about 5 years ago, and now we continue working with the agricultures for good water practices in the agriculture. And that's just a short rundown of the things we are involved with, and happy to be here with you.
All right. Good morning. My name is Xavier Cardoso. I am Marketing Director for NALCO Water, and I'm here in front of you with one goal. I have one thing I want to achieve in these 10-15 minutes I'll be talking, which is awareness. I want to create awareness. It's a very nice introduction to hear from Coca-Cola, from Josep, what Coca-Cola has been doing. It's nice to have a vision, but this morning it was said it's all about implementation. So Coca-Cola is having a vision, zero water contribution, and is implementing it very nicely. So opens to my speech, which is about how the industry has to be elevated in the agenda when we talk about water. And that's what I want to achieve. This morning, a lot has been said. Some of it, I will say it again to reinforce. But very little has been said about the role that industry plays in the water story. Domestic use of water, cities, agriculture, now it's time for industry, so I appreciate that we are giving this chance to talk about the role of industry in water. And I start with an impactful comment here. There's no new water, all we have is here, and that says it all. There is no more situation of balanced demand. We are already, globally speaking, in a scarcity mode. The water that's available is the water that we need. And if we look what's going to happen in the next 10, 15 years, which is tomorrow, we are in Christmas, then we are in 2017, and very soon we are in 2030. The world is going to need 35% more food than today. This is official figures. 50% more energy, 40% more water. And there's no new water, all we have is here. So the message today is that when we look from a global perspective, 70% of that water that we need is needed for agricultural purposes, and 20% for industrial, 10% for domestic. This flips when we are discussing Europe, where we are today. In industrialized zones like us, water for industry is up to 50% or half of the water needed to continue to operate our first world. So half of the water that we need is used for industrial purposes. So I will say half of the discussions in this Iwater forum should take place about how do we improve industry use of water. And there is a lot to say in that area. Starts by whatever goods industry produce, whether it's cars or steel, fertilizers, food. Every ton of goods produced uses from no less than 2,000 and up to 20,000 liters of water to be produced. And that's a lot. Hence the 50% of total water usage in the industry. And if we look where this water is used, is in the cooling process, in the heating process to create steam to help the chemical processes to operate, and in the process itself, like Coca-Cola, to ended up in the final product. So, but 3/4 of the total water use is for heating and cooling. The reason is that water, compared to air, for example, is the most efficient heat carrier that we can find. Not only cheaper, but very efficient. It's a way to transport heat or to remove heat, which are the things we need to do in industrial processes. That's why this is the major use of water. It's also used in the industry for washing purposes, as a carrier, like in the paper making or in the mining process. It's simply a carrier or the material of the fibers in the paper process that are being produced, or also washing, or ending up in the final product, like in the food industry. So because 3/4 are heating and cooling, this is really where we focus. And I bring back the discussion to the water pricing, which has been coming up this morning quite a lot. And the point I want to make is that the problem starts here. The problem starts because the places where the water scarcity is higher, for social, economical, political reasons, this is where the water price is lower. And the place where water is most expensive happens to be here in Europe. And funny enough, Denmark, for example, is the country with the highest water price in the whole world. And it's not due to the scarcity of water in Denmark. That's how it is. But when we look about Europe, we are in Spain. We talk about Spain quite a lot. This morning came up desalination as really an area where industry has to invest to make it more energy efficient, to make it more sustainable, and make it grow as an alternative source of water. Also, when we look about Europe, as an example, London has more water scarcity than Rome. Nobody will figure it out. Has less rainfall, London, compared to Rome. Or Belgium is actually the second most water-stressed country in Europe, not Spain. So what it means is, as you see in the map, it concerns everybody. Because water pricing in the industry plays a key role on the awareness and the motivation of the industry to improve. What we have created, my company, NALCO Water, together with a consultancy company called TrueCost, is a tool called the Water Risk Monetizer, which utilizes not only the actual price of water, but economical factors like GDP, industry benchmarks, industrial factors, or scarcity situation and scarcity trends, projections, to come with an estimated risk value of the water. And that is what we are helping industries to use to make good business decisions around the water, for sustainability, environmental reasons, and for economical reasons, because all lies into merging the sustainability factor with an economical factor, and that's what this is about. The industry will move and will move faster when we merge the two things together. And this is, I want to bring in the equation the water energy nexus that came up also before, from another angle than the Coca-Cola. The reason is, energy is not cheap. Water may look cheap. We just said it's not, but it looks. Energy, nobody will argue that it has a price. And in most of the industries, it's actually one of the top 3 cost drivers in their P&L. So water and energy go together. And how they go together in different ways. I said before, water is mostly used in heat exchange processes, so optimizing heat exchange processes helps minimize the use of energy, simply because the heat transfer happens more efficiently, you need less water, you can produce more energy. Secondly, what also happens is that when we recycle water, that water is generally of higher temperature than the incoming water. So we are also recycling energy in the form of heat. So that higher temperature we can use in a smart way in the industry as a second way of saving energy. And lastly, somebody said before, we are transporting water, and that requires energy, pumping energy. The more we transfer, the more we use energy for the simple need of transporting it. So these are 3 ways in which minimizing water helps minimizing energy. And that's the nexus, technical and economical. So that here comes my point. The industry has a water challenge. We all have a water challenge. It's also an opportunity. And how we can make it an opportunity? Simply by, first of all, meeting the driver of sustainability that everybody has. This is a key imperative to improve our environmental footprint, and that positions the companies that do it in a better way. But secondly, using it to minimize costs through this water energy nexus that I spoke about. And lastly, if we do those two things together, we minimize water, we optimize our cost, that's actually a competitive advantage for the companies. So rather than being a cost that companies have to take, it's actually an investment that delivers return. And that's the story. How the industry can undertake such project in a smart or stepwise approach? First of all, using what we can call the low-hanging fruit, which will be simply optimize the process and reduce it. Most of the industries, they have cooling towers, and that's where they use most of the water. You can increase cycles of concentration in a cooling tower. And that by itself simply requires little investment, operational investment, and can bring significant savings. And that's relatively simple to do, and that's actually what we do every day. Secondly, we can go one step further, which is reusing water. That means taking the effluent of one section of the plant and using it as an influent on the next section, taking into account the water quality requirements that are needed for that recipient of the water. And that's reusing. That's technically a little bit more complex, but it's doable. And the last one, which delivers the higher return, probably with a bigger investment, is recycle. I like what Professor Dirk from California said earlier this morning, which is we need to stop thinking wastewater as a liability, I think you said. We need to start using it as an asset. So wastewater is actually an asset. It's a new source of water that, as we hear this morning, is coming more and more in the agenda. So actually recycling, reducing, reusing, recycling, we can move towards a state of zero liquid discharge, so 100% water management, which is, we heard before, this is the way smart companies, leadership companies are moving to. We can use also what is also called MLD, or minimum liquid discharge, more than 90% reutilization. And that's more an economical way of managing the project. My company, NALCO Water, does it this way, and I do a little bit promotion now, with a value proposition of minimizing water and maximizing results productivity of a production line and optimizing cost of operation. So linking the water driver with the economic driver to bring a whole water, energy, waste, and operational cost reduction that is higher than the investment, therefore is allows to minimize water, improve water footprint, while improving competitiveness of the industry. And that's the way we can move, and we can move actually quite fast. We do that by, to use a well-known expression, connecting the dots. So we have chemical treatments in the cooling towers of our customers, in the boilers, in the incoming water plant, in the wastewater plant. And we have 3D tracer technology, which is automation with sensors that allows to continuously monitor, continuously control, and improve the performance of those operations. We can take that to the cloud, a secure connection, a smart data processing of those informations, and that's where Industry 4.0 is moving. That's really the digitalization, new industrial revolution, which will allow that to become knowledge that we can use to continue to reduce, reuse, and recycle and move towards higher standards, higher goals. So in summary, what I would like us to remember is that water is a significant element in the production line, and industry is a significant element when we talk about water. So we wish that industry is higher and higher in the agenda of this Iwater event as the years go by, and we will be here to support it. At the same time, water, energy, nexus is critical because it can help the industry move faster by introducing an economical advantage to minimizing water. And with that, we can use those combined benefits to actually accelerate the process. So I end up with a nice saying, as I started with a nice saying, it's a Japanese one: don't wait to be thirsty, don't wait until you're thirsty to build a well. Don't be reactive to the water driver, be proactive, know what to do, and start moving right now, as we heard before. Thank you.
Good morning, everyone. We got some nice examples about what industry is doing and the efforts that are taken today by industry. And it was also a very good explanation why industry deserves support. And the reason is the socio-economic importance of water. Looking at the challenges, pushing up is okay. Are the jobs. There was recently a report by the United Nations World Water Development Report 2016 in which they look at the link water and jobs. Jobs are in water sectors, 3 functional categories they describe: the water resources management, including integrated water resources management, and ecosystems restoration, building, operating and maintaining water infrastructure, and also the provision of water-related services, including water supply, sanitation and water management. It's clearly that enabling employment in water-dependent sectors is fostering the economic growth, and that is what industry is also looking at. And if you look at the report and you look at the sectors requiring access to significant quantities, then they are worldwide looking at 1.4 billion jobs, or 42% of the total active workforce, that are heavily water dependent. And if you look at the sectors where water is a necessary component in part of their value chain, not requiring access to real significant quantities of resources, then it's once again an additional 1.2 million jobs that are there. If you look at the European report on SMEs, because of course there are the large companies, but if you look at the real labor force and the companies involved, then you're looking at a lot of SMEs. And in this 2014-2015 report, it is mentioned that more than 22 million SMEs active, employing almost in Europe 90 million people, are accounting for 58% of the value added generated by the EU 28 non-financial business sector. The EU's traditional water sector includes a large amount of players, including 9,000 active SMEs, and provides almost 500,000 full-time equivalent jobs. Is everyone convinced about this? Well, there is the global risk report, and if you look at the report 2016, because they have every year a report, then you see on the left graph, you see the risk and the likelihood of some different aspects. At the right side on the top, you have water. And if you look at the top 5 concerns, this is the right side, then for the coming 10 years, water is the most riskful issue. And that has a little bit been explained also by the previous. But if you look at the strong interconnection between crisis of water, food, failure to climate change and so on, this is in the real link. It is done. Okay, I come back on. It is the clear link which is mentioned. But if you look at the right side, there is no link. There is no link with employment. So is this economic forum well aware about this issue? I don't know, but it should be, as it is confirmed in plus. If I look at my country, Belgium, this is Belgium at the right side, and you look at Flanders, then you have to know that this part, and this is a little bit confirming by previous figures, that is that we are the 4th poorest OECD country in relation to water availability. so water to be used for drinking water, for irrigation, for cooling, and so on. We are the fourth poorest, but we managed to produce 25% of all the deep frozen vegetables of Europe are produced in Flanders, Belgium. And there's also the location of the second largest chemical site. So that means that we have a significant expertise, a good legal system, also policy, we have know-how, technology, solutions to deal with this, let's say, small availability. We made a study on this, and we have been looking at all the different sectors. So the 100 NACE codes we went to, and if you look at the water intake, including the cooling water, then you see that the energy sector, the chemical industry, the industry operating in the manufacturing of cokes and so on are the most consuming ones. If you look at the water consumption itself, so excluding the cooling, then we have the chemical sector, followed by drinking water companies, agriculture, the food manufacturing, and the metal industry, as it has been mentioned as well. If we look at the employment in the 10 most water-using sectors, then we see that the average is 1 on the 6 jobs directly linked with the water consumption, directly. And that is in all the provinces of Flanders, Belgium, almost equal, except there's a difference of sectors where Antwerp area, for example, there is more chemical, there's more textile in West Flanders, and so on. And then also what we did is we looked at each sector to the added value and also to the water cost in relation to the added value. So when you have already a low added value, your sector is, let's say, in risk. And if you go to the right side where the water cost is let's say, very close to the added value, that means that a little increase of the water cost, and the water cost has been mentioned and presented here, that a little increase of the water cost may really put you in danger. And if you look at this, if you look at the external cost of the buying of the water, which is, or the intake of the water, then you have 1.25 or 5.5, which is the Belgian Flanders situation, in relation to the gross added value. If you look at the internal water cost, and it has been also mentioned by the previous speakers, if you have the pumping, the treatment, the cooling, and so on, then you easily go up to the 10% of your gross added value. And based on the employment, on the use of the water, the employment, and the relation to the added value, then we have steel, agriculture. These are the 9 sectors which are for us the priority sectors to deal with. And when we talked individually and put the things together, then there are 4 major priorities issues by these sectors. The water availability is one. Is there enough water to do my business, for growing my business? The water cost, meeting emission standards, also very important, and also the integrated approach, for example, taking into account the transport, the waterborne transport, because this is often the system used for transport of goods is the river system. And if I go back now to the report of Water and Jobs by the United Nations, they talk about a water and jobs nexus. So I add an additional nexus to the ones that have been mentioned before. And therefore, there should be a lot of attention on innovation, improving water efficiency and productivity, water resource diversification, addressing capacity development needs and improving dialogue, monitoring, assessment and reporting, and policy responses on that. So it's an overall integrated issue to work on this water. And focusing on the economic sectors that are most relevant for environmental sustainability and job creation will prove to be the ultimate key to success. If I look back to our governments, there is a Vision 2050 of the Flanders government with 9 teams in there. And it's for the first time that a robust water system is one of the priorities for the government. They have 7 transition priorities, and one of them is to continue the transition towards a circular economy, including water. And the Parliament Act confirmed this on April the 1st this year, including mentioning that entrepreneurs, researchers and government work together in the Flanders Knowledge Center Water, which I represent. And if I look, our task is to, let's say, initiate, coordinate, facilitate. We are an independent division within VITO, which is about 770 people, some offices working worldwide. So we are very open in partnership, finding solutions, initiating, introducing solutions in Flanders, and at the same time we are available. Thank you very much.